take a look at the sphere in the middle of the scene. This is Andy's room without any materials on the objects, and this is the same exact scene but with materials applied to everything, and the lighting hasn't changed at all. Can you see the difference? It's like day and night. The sphere in the middle is no longer just plain white. It's been heavily affected by the color of the floor, the walls, and all the other objects around it. That's because light rays don't just stop when they hit a surface. They bounce around multiple times, and when they bounce, they carry the color of the surface they hit and throw it onto the other objects. That's why when we get to the lighting and rendering stage, especially in indoor scenes, it's super important to first apply materials to the big surfaces like the floor and the walls, because they have a huge influence on how everything else will look in the scene. So in the first part of this episode, I'm going to quickly show you how to build the materials for the remaining objects, then we'll dive into working with the camera in Blender and preparing our scene for lighting. Okay, let's jump right in. Okay, first things first. We need to make sure the textile density of our objects is correct. If you don't know what textile density means, or maybe you forgot, I recommend checking out episode 5 and 7 from the previous season. Back in that season, when we were creating materials, we made sure the textures had the right resolution. We also set the textile density in a way that when the camera gets close to an object, the texture still looks pretty sharp. Of course, we didn't push the textile density too far because we weren't planning for extreme close-up shots. Now, let's say we want to match the textile density of the floor and walls with the rest of the objects. To do that, we'll apply a checkerboard material to all objects. Luckily, Blender has made this super easy, thanks to a feature called Material Override. But heads up, this feature only works in cycles for now. So first, make sure your render engine is set to cycles, then go to the View Layer Properties, and in the Override section, we can choose a material that will temporarily be applied to every object in the scene. So before doing this, you should already have a checkerboard material ready. I showed how to make one in Season 2, Episode 4, around minute 9. To save time in this video, I've already made one. So now just search for it by name and select it. Okay, now keep this in mind. If you switch to Material Preview, you won't be able to see the effect. That's because, as you might know, Material Preview uses the Eevee render engine. And since this override feature only works in cycles, you have to switch to Rendered View to actually see it. Now that we're in Rendered View, look. The checker material we selected has been applied to all the objects. It's now overriding everything. So now we can go ahead and adjust the UV island scale and fix the textile density. But as I said earlier, Eevee is much faster to work with. And that's why in the latest update of the SmartFlow Add-on, there's now a brand new tool called Eevee Material Override. With this tool, you can either choose your own material, or if you turn on Use Preset, it automatically loads a ready-to-use UV grid material for you. Then just click on Apply Preview, and boom, it overrides all objects in the scene with that material. And the best part, we can see it right inside Eevee, so you can work way faster, and it's also easier on your computer. By the way, all updates are completely free for anyone who already owns this add-on. And more useful tools are on the way in next updates too. You can find the download link for SmartFlow down in the description. But just to show you that this is totally optional, you don't need the add-on to follow this process, I'll continue without using it. Okay, next step, we need to resize the UV islands of the floor and the walls so the squares in the checker texture look similar in size to the ones on other objects. The goal is, when you look at the room as a whole, the checkerboard texture looks even and consistent across everything. Once that's done, just remove the checker material from the Material Override slot. Now, for the wood material on the floor, if you watched the last season, you can either build your own procedural wood material or use the free Blender Kit add-on, which I introduced back in episode 11 of last season. Just go to the Material section, search for wood, and drag and drop any wood material you like directly onto the floor. Easy. Then, don't forget, if the direction of the wood grain doesn't look right, you might need to rotate the UV islands until it looks natural on the planks. One thing you'll notice is that right now, all the wood planks look exactly the same, no variation at all. But here's the good news. There's a simple trick using the Array modifier to fix that. In both of the array modifiers we use to build the floor, go to the UV section and adjust Offset U and Offset V. Just by tweaking those values, you'll start to see more variation pop in. And to make this effect even clearer and more natural, let me show you a cool little trick. In the shader editor, add a hue and saturation node and place it right before the connection to the base color input of the principled BSDF node. Now, add a color wrap node and connect it to the value input of the hue and saturation node. Right now, if I move this color stop, it affects all the wood planks equally. But we want it to apply randomly. To do that, just add a geometry node and plug the random per island output into the factor input of the color ramp. Now, change the black color stop and make it a bit lighter, closer to white. Still looks like nothing is changing, right? Even if I make it darker, it seems like nothing is happening, but actually it is. You just need to switch to render display and check it in cycles. Now we can see the variation. Okay, adjust the color closer to white to control how much it affects the planks. And finally tweak the saturation and hue values to get the look you want. And just like that, you've added a beautiful variation to your wood planks with this simple trick. Next up, for the wall texture, start by downloading the wallpaper texture using the link I've dropped in the description. Connect it to the base color and hit Ctrl-T to add the mapping nodes. Make sure UV is connected to the vector input, then go to the UV editor. You can place scenes on the 4 corner edges of the wall, unwrap the UVs, and rotate them so the texture pattern displays correctly. Since this is a seamless texture, you can select each wall's UV island with L, press G, then B to select a base point, and line them up next to each other. This will make the wallpaper look continuous across the walls. Okay, to add more details, let's bring in a noise texture. Again, press Ctrl-T to add the mapping nodes. Increase the scale on the x-axis, tweak the properties until you get a nice pattern, and then connect it to a bump node. Finally, connect that to the normal input of the principal PSDF and adjust the strength. Just don't forget to preview it in cycles. And lastly, make sure you also adjust the roughness of the wall. Okay, for the material on the door and window, I used the same wood material we made for the dresser. But remember, after assigning it to your object, click the little number next to the material name to make a unique copy, so any changes you make won't affect the dresser's material. Next, for the glass on the window, you can search for glass in Blender Kit and drag and drop the one you like onto the window glass. And that's it for this part. And hey, if you get stuck along the way, don't forget to join our free Discord group, links in the description, and drop your questions there. Alright, now let's move on to the camera. As I mentioned earlier in this course, you can either click on Render Image from the Render menu or just press F12. But when I do that right now, you notice something down here. A red warning pops up saying, "No camera found in scene." That's because, yep, I don't have a camera object in the scene yet. So it's pretty clear you can't render in Blender without a camera. Let's go ahead and add one. But before that, I'm going to create a new collection, name it Camera-Lights, and make sure it's selected. That way, when we add the camera and lights, they'll be placed in this collection. To add a camera, it's super simple. Just like adding anything else in Blender, press Shift-A, then choose Camera. As expected, it gets added right at the location of the 3D cursor. Let me press G and move it over here for now. Okay, now let's see how we can actually control the camera. I'll show you two of the simplest and most common methods, and you can pick the one that feels more comfortable. Personally, I prefer the second one. So first, to control the camera, just press 0 on the numpad to switch to the camera view. But the moment you middle click and drag, it jumps right out of the camera view. To prevent that, after pressing 0, hit N to open the side panel, go to the View tab, and under View Lock, check the box for Camera to View. Now, when you middle click and drag, you see that it stays inside the camera view. That means we're now moving the actual camera itself. Super useful. So from here, you can navigate the same way you usually do in the scene, just move around and frame the shot however you like. Once you're done setting up the perfect view, make sure to uncheck Camera to View so the angle doesn't get messed up accidentally. Then, you can freely middle click and move out of the camera view. So that's the first method. Now, personally, I don't really like having to open the side panel, move my mouse around, and keep checking if Camera to View is active. That's why I'm more comfortable with the second method, which doesn't involve the side panel at all. So let's move on to that one, my favorite way to control the camera. So first press 0 on the numpad to switch to the camera view, and this time we can easily take control of the camera by pressing Shift plus tilde key. Now look, a pointer appears right in the middle of the viewport. And just like in a first-person video game, if I move the mouse, you'll see we can rotate the camera and change its view angle. And even better, now, just like in a game, we can move around the scene using either the arrow keys or the classic WASD keys to position the camera and set the angle we want. Personally, I don't use the arrow keys. I find WASD way more comfortable because with the E key, I can move up, and with Q, I can move down. These keys are right next to WASD, so it's super easy for me. Okay, so W moves forward, S moves backward, A goes left, D goes right, E goes up, and Q goes down. Also, if I scroll the mouse wheel back, it slows down the movement speed, and if I scroll forward, it speeds it up. Okay, when you're done, just left-click to lock the camera in place, and then middle-click to exit the view. No worries, your camera's position won't change. Alright, here's an important question. What if we have more than one camera in the scene? Let's test that. I'll go ahead and add a second camera, and move it over here. Okay. Now, every time I press 0, you see it still takes us to the first camera's view, the one we added earlier. So, how do we switch to the second one? Well, we need to tell Blender which camera is the active one. You can tell which one is active by looking at the visual triangle guide above each camera. The one with the filled black triangle is the active camera. So no matter how many cameras you have in your scene, whenever you press 0 or when you render, Blender will always use the active camera's view. To set a camera as the active camera, it's really easy. Just go to the outliner and click the green camera icon next to the camera you want. Once you do that, 3 things happen. The camera properties panel opens up, that camera's icon in the outliner gets highlighted, and also you'll notice the little triangle above the camera turns black, meaning this is now the active camera. Cool. So I'm going to click the icon and make this camera the active one, and I'll go ahead and delete the other one. Okay, now that we have the camera properties open, let's take a look at some of the important settings for the camera. But before that, here's a very important tip. Make sure you're using the right render engine. Things like shaders, lights, and even camera settings can change depending on which render engine you're using. Since we want to render this scene with cycles, I'll go over to the render properties and double check that the render engine is set to cycles. To speed things up, I'll also switch the device to GPU compute. If this option is grayed out, don't worry, just go to the Edit menu, Preferences, System tab, and under Cycles Render Devices, make sure your graphics card is checked. Okay, once that's done, Blender will show you the correct settings for your cameras, lights, and shaders based on the engine you picked. Alright, I'm going back to the camera properties, and let's keep going. First, let's talk about Clip Start and Clip End. Clip Start controls the minimum distance the camera can see. So basically, anything closer than this value won't be shown. You might have run into this before, when you get really close to an object, like this one, and it suddenly looks like it's getting cut or clipped. In that case, just reduce the clip start value to fix it. You especially need this when your objects are very small in scale. But be careful. Never set clip start to 0 or you'll run into display issues like this. Okay, let me just move the mouse here and reset it by pressing backspace. Now, clip end is the opposite. It sets how far the camera can see. So if your scene is very large, like if I zoom out a lot, like this, and add a plane, and scale it up huge, you see that parts of it disappear when they're too far away. That's when you'll need to increase the clip end value so the camera can show more distant objects without cutting them off. Alright, let me move the camera back to where it was before. Okay, done. Just note these settings apply only to the selected camera, not to all cameras in the scene. And if you're not in camera view, if you're in perspective view, then the clipping settings are a bit different. In that case, press N to open the side panel, go to the View tab, and here we can find Clip Start and Clip End. These ones are just for the viewport and don't affect your scene cameras. Now let's talk about the most important camera property, focal length, which is in the lens section. With this, we can easily change the focal distance of your camera's lens. The smaller this number is, the wider your shot gets, and you'll notice more distortion in the corners. As you can see, the room even looks bigger this way. If you increase the number, you'll get a tighter shot, and the image will look much flatter. Since we want to render the whole room and show off the space we modeled, I'm going for a wide shot here. So I'll change the focal length to 30mm. Okay? Just keep in mind, the part that gets rendered, it's only what's inside this boundary line right here. Anything outside of it won't show up in your final render. So if you want, we can use Ctrl plus middle click and drag to zoom in a little, so the stuff outside the frame doesn't distract you. But what's even better is to adjust your workspace layout so it's more comfortable to work in. For example, I'm going to split the viewport into two. I'll hold middle click and drag to jump into perspective mode over here. Then I'll click and drag to split this area again and switch it to the shader editor and press N to close the side panel. Why shader editor? Well, you'll find out soon enough. Alright, let's clean this up a bit. While my mouse is over here, I'll press T to close the tool panel, and to hide the word navigation gizmo and the other overlays over here, I'll press Ctrl plus tilde key. And remember, these shortcuts are toggles, so if you press them again, everything you hit will come back. Okay, now I'll bring my mouse here, right-click, and uncheck Show Header. If you look closely, there are little arrows here. You can also click those to bring hidden panels back. Now you can see this area looks way cleaner, and whenever we want, we can hit Z and switch to rendered mode to preview our work in a much calmer, distraction-free space. But if you look closely, you'll notice Blender is also rendering everything outside the camera frame, which slows things down for no reason. I mean, that space will never be shown in the final render, right? So let's fix that and stop wasting our system's power. All you need to do is go to the camera properties and in the viewport display section, change the passepartout to 1. Boom, done. Now I'll hold Ctrl and use middle click to zoom in a bit and fit the frame nicely. Okay, so right now, even though I haven't added any lights to the scene, it's already lit like this. Now I want to click on render and check, is the result I'm seeing here in the viewport exactly what I'll get in the final render? But before clicking render, make sure to switch back to solid display mode. Because if you stay in rendered view and then hit render, Blender will try to do two renders at once. One in the background in the viewport, and one in the actual render window. That's a lot of extra pressure on your system, and it'll slow things down. So I'll switch to solid mode here, and then I'll click on render. And since we already added the camera to the scene, we don't get that warning anymore, and the render starts smoothly. But look at this. The result is totally different from what we saw in the viewport. Spooky, right? This is a very common mistake that many beginners make. They spend a lot of time adjusting the lighting, and when they finally hit render, surprise, the result looks completely different. Let me close this window for now and show you how to avoid this issue. I'll click here to bring back the header and switch the viewport shading mode to rendered. Then I'll click this little arrow here, and to make sure what you see in the viewport matches what you'll get in the render, just make sure these two options are enabled. That's it. The first one, Scene Lights, lets you preview how the actual lights in your scene affect everything. If it's off, none of your scene lights will have any effect in the viewport. The second one, Scene Word, uses the settings from your word properties. If it's turned off, your scene will be lit using whatever HDRI image you choose here instead. We'll talk more about word properties soon. Just keep in mind, these two settings only affect the viewport preview. They don't change the final render itself. But when you click render, the result you get will match what you saw in the viewport only if both of these are turned on. So to stay on the safe side, just keep both enabled. That way, no surprises. I hope that made sense. Alright, now to clean up the viewport a bit more, I'll click this icon to turn off viewport overlays so we don't see empties, cursors, and all that extra stuff. Then I'll right-click here again and hide the header one more time. Okay, and now as you can see, the scene looks pretty dull, flat, and dark. It's time for some light to come in and change everything to bring life back into our scene. Yes, it's finally time to explore lighting and how to light your scene properly. And that's exactly what we'll dive into in the next episode. So I'll see you there. Thanks to all the amazing people who supported us this month. A special shout out to Eric Retania for supporting us on Patreon, and to everyone who baked the BlenderTutorial course during the past seasons on Gumroad and Artstation. If you'd like to support what we're doing, you can join us at patreon.com/MiM-Repository. All supporters get a mention at the end of each video, and you'll receive a full month of shoutouts starting from the moment you join, even if it's at the very end of the month. Thanks again for watching, and see you soon.